Haven't you seen the flowchart?
In the flowchart, first you have to start and analyze a problem, and for each step that you do, you have to check that if it's correct. If not, you have to go back. It goes the same for every step, and here along the way is specified.
What? Yes, but I still don't understand.
Wait, I know what we're gonna do.
Yeah, let's go.
All the math ladies, 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 all the math ladies. Now put your hands up. Up in the class, I just don't understand. I'm doing my own little thing. We decided to help, and now we're gonna pass, cause we're gonna get this right. I'm up on A and A is easy, no need to worry about it. Just think it through, and B is easy too, along with C and D.
First, we needed to get the restrictions to get a domain. To get the restriction, all we took in consideration was the denominator, equaled it to 0, and solved it out. We saw that x couldn't be equal to -1 or 1, so we know that our domain was x equal to all real numbers except -1 and 1. Point B was to get the x and y intercept coordinates. For the x-intercept, all we had to do was equal the function to 0. After solving it out, we saw that there was two x-intercepts, which would be point A, 2, 0, and point B, -2, 0. For the y-intercept, all we had to do was equal the x's to 0. And after solving that out, we saw there was only one y-intercept, that was C, 0, 4. For point C, we needed to find the symmetry with procedure. If we want to see if the function has an odd symmetry, we have to make the whole function negative and see that it would give us the original one. But since that didn't happen, we went with the procedure to get an even symmetry, which would be only making x negative. Doing that, we did get our original function, making us know that we had an even symmetry on the y-axis.
First, we factorize our function. Then, the denominators, we equal them to 0.
After you factorize, now that you saw that you can cancel things out, and all you have to do is equal it to 0 to get what is a vertical asymptotes and that there's no gaps.
Yeah.
Oh, I got it!
Cause if you got it, then you should just practice it. If you got it, then you shouldn't be sad about it. Don't be mad when you see that we got it. Cause if you got it, then you should just practice it. Then you should just practice it. I got an answer in my head, a marker in my hand, and I'm ready to start point E. I'm stressing out, but I can do this, even though I would like Miguel's help. I need no revision, didn't mention I found out how to get F and G. Cause you have to derivate, and now you're gonna learn what I really feel like to get it right.
First, we have to find our biggest exponential, that is x squared. Then we divide each term by this. We simplify and use the limit that x tends to infinity and substitute every. To find the first derivative, we have to use our quotient rule, as we already know.
So our result would be 6 over x squared minus 1 squared.
For the ID text, we have to equal the first derivative to 0. Then isolate x, which in this case gave us 0. Then, for the table, we have to put the intervals that goes from -infinity to 0 and the second one from 0 to infinity. Then we need to choose a number that is between each of them and replace it in the first derivative. In the first interval, it gives a negative number, which means it will increase. In the second interval, it gives us a positive number, which is indicating that it will increase.
Cause if you got it, then you should just practice it. If you got it, then you shouldn't be sad about it. Don't be mad when you see that we got it. Cause if you got it, then you should just practice it. Don't think that I haven't understood. I'm not that kind of girl. Truth there is what I prefer, what I deserve is to do the extra points on my own and finally get this right for infinity and beyond. We're almost done. Please say I got them right. If I did, let's move on. And like the time, let's do less point key.
To obtain the second derivative, we need to only follow the quotient rule formula, which is g multiplied by the derivative of f minus f multiplied by the derivative of g all over g squared. For the concavity test, we only have to equal the second derivative to 0, but in this case, the concavity test cannot be performed because the second derivative has an imaginary root.
The first graph refers to the function x squared minus 4 over x squared minus 1. The graph refers to the first and second derivative of the function, and the connection between them is how they relate in the derivative test.
Cause if you got it, then you should just practice it. If you got it, then you shouldn't be sad about it. Don't be mad when you see that we got it. Cause if you got it, then you should just practice it. Oh, 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 oh.